So we have seen a variety of graphs that have discontinuities to them, where there is a point, and at some point the graph is discontinuous. So we're going to categorize these discontinuities and put some vocabulary words to them so that we know how to describe them. So the first is what we call a removable discontinuity. And that's a discontinuity at a point in the function where the limit does exist. Okay, so a removable discontinuity, the limit exists, but the function may be defined or it may not be defined. So a couple examples of this. Here is a discontinuity where the limit as x approaches 0 exists, but notice that f of 0 does not exist. So it's like the point has been removed, and that's why we call it a removable discontinuity. Here is another one where the limit exists as x approaches -2, but again the point has been removed. Now it's actually relocated, so f of -2 does exist, f of -2 is -2, but there's still a discontinuity in the graph. So again, it's where the limit exists, the function may or may not be defined. That is a removable discontinuity. But then we have these things called non-removable discontinuities, and that is a discontinuity where the limit does not exist. And so in this particular example, we can see that the limit as x approaches -6 from the left is a different value than as x approaches -6 from the right. Therefore, the graph jumps, and so we call this non-removable discontinuity specifically a jump discontinuity. The other type of non-removable discontinuity is what we call an infinite discontinuity. Now, we haven't done a lot of graphs regarding infinite discontinuities yet, but as we can see here, as x approaches 5 in this first graph here, as x approaches 5 from the left, it is going towards -infinity, and as x approaches 5 from the right, it is going towards -infinity. But there is a vertical asymptote at 5. That is pretty obvious here. So we know from our past studies of vertical asymptotes that the graph can get really close to that vertical asymptote, but it can't touch it. So because of that, there's a discontinuity in the graph, in this case at 5. Or in the second example, we can see that as x approaches 2 from the left, it's going towards -infinity, but as x approaches 2 from the right, it's going towards +infinity. So obviously there's a vertical asymptote there. The graphs can't cross the vertical asymptotes, therefore we have an infinite discontinuity. So to help you keep this all straight, because there's a lot of new words that we just threw at you, let's kind of put this into a chart, a flow chart of some sort that you can organize in your head. So there are basically two different types of discontinuities. We have a removable discontinuity, and that's where the limit does exist. And then we have a non-removable discontinuity, and that's where the limit does not exist. Non-removable does not exist. In a removable discontinuity, it can be a hole in the graph. It will be a hole in the graph. And in that hole, the function may or may not be defined. We don't have specific names for those. We just call them removable discontinuities because the point has been removed. In a non-removable discontinuity, we do have names for these types of discontinuities. One of them is a jump discontinuity, and that's where the limit as x approaches from the left and the limit as x approaches from the right have two different values. Therefore, the graph has to make a jump to a different value. Let's just put it that way, a jump to a different value. And then the other type of discontinuity that's non-removable is called an infinite discontinuity, and that's where we have vertical asymptotes. So this is a kind of a handy way for you to remember the different types. These are just vocabulary words, and so you have to get used to reading them, using them when you speak, and writing about them.